Hi dear students, in the last class we had discussed about the measurement of lengths, isn't it? As well we were discussed about the parallax method, as well that vernier caliper, screw gauges, all those things we have discussed. Roughly we discussed all those things. The vernier caliper, screw gauge and all those things we will a detailed study will be there in the laboratory section. In the practical section we will study about that. So, already we have discussed about the parallax method. Actually, for measuring larger distances we are using the parallax method, isn't it? Now, we have to suppose if you want to measure a very small distance, suppose an atomic size, what can we do? Okay. Actually, there is an experiment, it is given in your textbook page number 26, okay. Estimation of the very small distances. Actually, here in this experiment we are finding out the molecular size of the oleic acid, okay. The molecular size of oleic acid we are finding out in this experiment. For that we are mixing 20 centimeter cube water. Firstly we are mixing 1 centimeter cube oleic acid, okay, oleic acid, and afterwards from this mixture we are taking 1 centimeter cube of the solution of the oleic acid, and again we are mixing it with, okay, we are mixing that one. From this solution we are taking out, yeah, it is a solution now. From this solution we are taking out 1 centimeter cube of that solution, and that one is mixing again with the 20 centimeter cube of the water, okay. So, suppose if you are going for the volume of the oleic acid in the last solution, it will be 1 divided by 20 into 20 centimeter cube will be the volume of the oleic acid, okay. That will be the volume of the oleic acid. That is for the 1 drop of oleic acid. Suppose n drops are there, okay. Suppose n drops are there, then it will be multiplied with the n. So, this will be the volume. So, let it be there. Now, we are dropping, okay, one drop from this solution into the surface of a water, okay, on the surface of a water, and we are spraying. Before that we are spraying that lysopodium powder over the surface. Hence, what will be happening? The oleic acid will float over the surface of the water, and actually the thickness of that surface, or the thickness of that oleic acid floated over that water surface will be equal to the molecular size. Actually, the thickness will be equal to the molecular size, and if we want to find out that thickness, that means that will be the molecular size of the oleic acid, okay. So, for that we are taking from the last solution. That means firstly we have mixed 1 centimeter cube of the oleic acid in the 20 centimeter cube of water, and from that we are taking 1 centimeter cube of that solution. Again we are mixing that 1 centimeter cube of that solution into 20 centimeter cube of the water, okay. This centimeter cube is measuring the volume, okay. So, in the last, suppose if you are taking 1 drop from that last solution, that is the 1 centimeter cube solution which is mixed again with the 20 centimeter cube water. If you are taking 1 drop, then there will be 1 divided by 20 into 20 centimeter cube, that will be the volume of the oleic acid in that 1 drop. Suppose if you are taking n drops, okay. So, afterwards from this solution we are taking n drops, and we are dropping these n drops over the surface of the water before we are spraying the lysopodium powder. So, this what you say the oleic acid will float over the surface of the water. Okay. As like if you are dropping 2 or 3 drops oil on the surface of water, it will be drop the oil drops will float over the water surface. No, same thing. Now we are having the volume. We are having the volume with us, that is n into 1 divided by 20 into 20 centimeter cube. That is the volume of the oleic acid which we have dropped in the water surface. And suppose the area, A value you can find out. That means suppose if you are looking from the upper portion, this might be the water, this might be the surface which is containing water, and the oleic acid will be floating over the surface like this. Okay, you are looking from the upper portion. Okay, you are facing the upper surface of the water, the opening of the we can say the mouth of the tumbler. Okay, so where the oleic acid will be floating like this, and the area of that oleic acid will be A, and you have already found the the volume as n into 1 by 1 divided by 20 into 20 centimeter cube. Okay. So, we can say the volume V is equal to area into thickness, isn't it? Area into thickness is the volume. So, we are having the volume and area with us. So, we can find out the T value, which is equal to V by A, where V it is n into, for n drops V it is n into 1 by 20 into 20 centimeter cube. Likewise, we can find out the value of thickness. We have already I have already told you that the thickness of that layer will be as like a molecular, the thickness will be is equal to the molecular size of the oleic acid. Okay, is this much clear? This is regarding that experiment. You just go through that experiment. Okay, that means in the textbook you just read that portion. So now let us come to the example 2.5. Okay, if the size of the nucleus in the range of 10 to the power minus 15 to 10 to the power minus 14 scaled up to the tip of a sharp pin, what roughly is the size of the atom? Assume tip of the pin to be in the range 10 to the power minus 5 meter to 10 to the power minus 4 meter. So, in this question it is asked that suppose you are considering, have to consider that the nucleus, the size of the nucleus as equal to the size of the tip of a pin. Okay, you already know that the tip of the pin is very smaller compared to the size of a very larger compared to the size of the nucleus. Otherwise, the nuclear size is very smaller compared to the tip of the pin. Okay. So, this question is that you have to consider this tip of a pin as a size of the nucleus, and if a tip of a pin is the size of a nucleus, then you have to find what will be the size of the atom. So, you already know the atomic size will be larger than the nuclear size. Okay. So, we are thinking, and maybe you may have heard that if the nuclear size is up to the size of a football, then the atomic size will be as much as ground. Okay. Suppose the nucleus is of the size of a football, then the atomic size will be equal to the size of a football ground. Okay. So, now we are considering the nucleus as the size of a tip of the pin, and we have to find out what will be the approximate size of the atom then. Okay. So, we have given with the size of the nucleus as 10 to the power minus 15. Let us take 10 to the power minus 15, that is of the nucleus. Okay. Now, for the pin it is 10 to the power minus 5 it is, isn't it? 10 to the power minus 5 it is the given value. The maximum value only I am considering, it is given like a 10 to the power minus 5 to 10 to the power minus 4 and 10 to the power minus 15 to 10 to the minus 14. Okay, so maximum value will be minus 14 and 4 now. 14 and 4. Okay, no problem. So, this is the size of the nucleus, actual size of the nucleus and that of the pin, and the actual size of the atom, it is of 10 to the power minus 10, okay, meter, all are in meter. So, the ratio should be same, that means the nucleus, the actual nucleus size it is for 10 to the power minus 14 meter, and actual atomic size it is 10 to the power minus 10 meter. Okay. So, here pin size is 10 to the power minus 4 meter. So, whatever the range difference, it means how much times the nucleus is larger than the smaller than the atomic size, there here the pin tip also will be that much times smaller than the atomic size over here. Okay. That means we have to, that means suppose if you are taking this one as A, this one as B, and this one as C, and this one as C, D, the ratio will be equal, that is A by B is equal to C by D. Okay. So, A by B is equal to C by D, then I will be writing A by B is equal to C by D. So, A by B is 10 to the power minus 14 divided by, suppose if I want to find out the D value, that we have to find out the atomic size if the nucleus is of the size of tip of a pin, then D will be is equal to C into B by A, that means C into B by A. Okay. D will be is equal to C into B divided by A. Okay. So, CB by A will be, which we can be obtain that one as C value, it is 10 to the power minus 4 into 10 to the power minus 10 divided by 10 to the power minus 14. So, 10 to the power minus 4 into 10 to the power minus 10 will be is equal to 10 to the power minus 14. So, both will cancel each other, okay, cancel each other, and the remaining value will be 1. So, if the size of the nucleus is of the order of 10 to the power minus 4 meter, then the value of the atom, the size of the atom will be of 1 meter, that will be the size of the atom. Okay. Is this clear? And afterwards the range of lengths are given, that we have already studied that range of the lengths, that astronomical, sorry, the Fermi Angstrom, then astronomical unit, then the light year, parsec, and their definitions are also given for the astronomical unit and parsec. You just go through that thing and remember that things. Okay, it may be asked in the, can be asked in the examinations. Now, let us come to the next topic, that is the measurement of mass. Measurement of mass. Okay. So, you know that for the general usage, for measuring the mass, we are using the units as kilogram and gram. Kilogram and gram. Kilogram is the SI unit of mass, isn't it? Suppose if you want to measure the mass of an atom or a nucleus, it is not possible to measure that with the unit kilogram, isn't it? Because the size of the atom and nucleus is very small, as well the mass of the atom and nucleus will also be very small. So, we have to use one another unit, that is one unified, it is known as the unit is known as the unified atomic mass, unified atomic mass unit. Okay. So, before that regarding mass, actually we know that mass cannot be mass will not be affected, okay, mass will not be affected by the external physical quantities, whether temperature, whether pressure, okay, whatever the physical conditions, volume, whatever the physical conditions outside, the mass will not be affected by them. Okay. Mass is a constant value for a particular body. Okay. But at that time W, that is the weight is actually the product of mass and gravitational acceleration. As the gravitational acceleration changes from point to point, suppose in the equatorial point the gravitational acceleration is having one value, and in the polar region it will again vary, and if you are going to the space, okay, if you are going to the space, then again the gravitational what to say, simultaneous decrease in the gravitational force will be happening. So, the weight is not a constant value, but the mass is a constant value. Okay. So, let us come back to the one unified atomic mass unit. Okay. So, one unified atomic mass unit is defined as the mass of 1 by 12 times of the mass of the 6C12 atom. It is the mass of, or we can say the 1 by 12 times the mass of the unified atomic mass unit is 1 by 12 times the mass of the carbon 12 isotope, 12 carbon isotope. Okay. So, that is known as the unified atomic mass unit, and in kilograms it will be is equal to 1 U. In as per your textbook it is given as 1 U. 1 U will be is equal to 1.66 into 10 to the power minus 27 kilogram. Okay, that is the conversion of a unified atomic mass unit into kilogram. And as well, in the case of electrons, protons and all, you know that electron is having a negative charge, and as well the proton is having a positive charge. Okay. So, electron is having negative, and proton is having positive charge. So, measuring, actually they are very light quantities, means the mass of the electron or a proton, if you want to count or measure, because it is very negligible values. So, that is not much possible. So, we will be using the electromagnetic deviation methods we are using. That means, there will be the electric field as well the magnetic fields we will apply, okay. And we will allow the passage of, suppose if you are considering an electron, the electron will be allowed to move fastly, or we will the target tail, we will accelerate the electron, and it will pass through, it allows to pass through the medium, means in between the electric and magnetic fields. So, whenever a charge, actually electron is a charge, negative charge, whenever a charge is moving, there will be the production of the magnetic field, as well it is having, already it is having the charge negative. So, it will be deflected by the electric and magnetic fields. So, there will be a deflection happens, okay. Maybe an attraction or maybe a repulsion happens, and the radius of this charge tail, by measuring that value we can find out the mass of the electron with some particular equations and some particular experiments we can find out the mass of the electron likewise. Okay. Actually, here due to the gravitation, the electron is having, at this point the electron will be having a downward pull, and as well it moves to the upper portion, that is due to suppose maybe a magnetic attraction or electric field attraction. Okay. So, by comparing these two values and its charge tail, the path of its motion, okay, comparing all these three things, we can find out the mass of the electron as well the proton, like charged particles, okay, that we can do. Now, let us come to the range of the masses. The table number 2.3, the mass of some objects are given, and what the approximate length of, or the range of its lengths also given. For the proton, it is given as 10 to the power minus 15 meter, and the atomic nucleus proton it is 10 to the power minus 15, atomic nucleus we have already discussed, that is 10 to the power minus 14, and the size of the hydrogen atom, the atomic size is near about 10 to the power minus 10 times, okay. That means the power it is 10 to the power minus 10, and the range it is 10 to the power minus 10, as well as the typical virus, the size of the typical virus is near about 10 to the power minus 8, okay, meter. Then the thickness of the paper is near about 10 to the power minus 4 meter. Actually, in the last example we have discussed that the point, the pin point, that is having near about 10 to the power minus 4 size, okay. As well the thickness of the paper is also of 10 to the power minus 4 size. Then height of the Mount Everest. Now onwards we will be dealing with the lengths which are greater than 1 meter. Till now we were discussing with the distances that are, we can say, lesser than 1 meter, but 10 to the power minus 4 is lesser than millimeter, isn't it? Okay. So, lesser than millimeter we were discussing. From now onwards we will be discussing the lengths which are greater than 1 meter. Height of the Mount Everest above sea level, it is 10 to the power 4. Okay. As well the radius of earth, it is 10 to the power 7. Then distance of sun from earth, it is 10 to the power 11. Okay. You just go through that table, and if possible you just write these tables in the notebooks also. The SI unit table, and the first table it is not necessary, okay. The SI based quantities of unit, table 2.1 it is not necessary, but 2.2 and 2.3 you can write in the notebook. And regarding the range of masses are also given, where object, the mass of the object, it is of the order 10 to the power minus 30. As well proton, it is 10 to the power minus 27. Then the earth, the mass of the earth is of the order 10 to the power 25, and the sun, it is 10 to the power 30. We just go through those things, okay. Regarding the measurement of the time and accuracy, precision, those things we will discuss in the coming classes we will discuss. Okay, thank you.